Bismillahirrahmanirrahim. Welcome to my YouTube channel Calculus and Mathematics Learning. In the previous 5 videos, I solved past 48 MCQs related with ETEA Engineering test of 2017 mathematics portion. In today's video, I am going to solve MCQs from 49 to the MCQ number 60 or 59. So let's move toward MCQ number 49 of ETEA Engineering test of mathematics portion 2017. It tells that if x plus iota y is actually a complex number which is equal to pi minus 3 iota whole cube, then they tells that what will be the value of x and y. So move to the solution of this MCQ number 49. X plus iota y is equal to pi minus 3 iota whole cube. This is given. So we will use the formula which tells that a minus b whole cube is equal to a cube minus 3a square b plus 3ab square minus b cube. This is the formula. So using this formula, let's suppose this pi is equal to a over here, and let's suppose b is equal to 3 iota. So putting the values in this formula, we will get the required answer. So a is pi, so put over here, so it become pi cube minus 3 into a square. A is pi, so it become 5 square. And the formula we have b, so b is 3 iota, put over here. After this we have plus sign 3, and after this we have a. A is actually 5. And after this b square, so b is 3 iota, so 3 iota whole square, and after this in the last we have minus b cube, so minus time of b is 3 iota, so it become 3 iota whole cube. Now by further simplification, x plus iota y will come down as it is. Pi cube will give us 125, 5 square will give us 25, 25 multiply 3 gives us 75, and 75 multiply 3 gives us negative 225 iota. After this 3 multiply 5 will give us 15, and 3 square it will give us 9, and iota square will give us negative 1. And after this minus time of 3 iota whole cube can be written as 3 iota, 3 iota and 3 iota. Now further simplification, 125 will come down as it is, negative 225 will come down as it is, minus 9 multiply 15 will give us minus 135, and after this 3 multiply 3 will give us negative 27. Iota into iota gives us iota square which is equal to negative 1, and the 1 iota will come down as it is. Now by further simplification, 125 and negative 135 it will give us negative 10, and minus 225 will come down as it is. Minus into minus gives us plus 27 iota. Now minus 10 will come down as it is, and minus 225 iota and plus 27 iota will give us minus 198 iota. Now look over here. X plus iota y is actually a complex number. This x is called a real part and this y is called imaginary part. So over here the real part will be negative 10, which is actually equal to x. So x is negative 10. And the coefficient of y is actually called imaginary part, which is actually y over here, and on this side we have negative 198. So the value of y is minus 198. So that is that find the value of x and y. So x is minus 10 and the value of y is minus 198 minus 198. So it means the correct option for MCQ number 49 is option number D. Now move to the next MCQ, MCQ number 50. It tells that if a mod of z is equal to mod of negative z for a complex number z, if and only if it hold that z is equal to negative z, z is equal to mod of z, conjugate of z, and the third one is z is equal to negative conjugate of z. So option number A tells that only one holds. Option B 1 and 2 both hold, and option C 1, 2 and 3 holds, and the last option is either 1 or 2 hold. Remember that if we put z is equal to negative z, or z is equal to conjugate of z, or z is equal to negative conjugate of z over here, so it will holds for the 3 option, because the mod is an even function. It will makes the value either positive or negative. It makes both the value positive, so the square root and the result will be equal. Let's suppose if I put z is equal to negative z over here, so it become absolute of negative z is equal to negative absolute of z. It means this is defined. And if I put z is equal to conjugate of z over here, so it becomes z conjugate and absolute. And this negative z will come down as it is. If you take the mod of this z conjugate and you take the mod of negative z, it both will be equal. It means this is also holds option 2 number, and the third one will also be hold. It means the correct option for this MCQ is option number C, 1, 2 and 3 all of these are holds. Move to the next MCQ, MCQ number 51. If A is a 2 lambda 3 1, it is a non-singular matrix. Then lambda can take all the real values except for. Remember, If this is a non-singular matrix, so it can take all the real values. This lambda can take all the real positive or negative real value except those value h with this matrix becomes singular. So it can take all the real value except for the singular matrix. So at singular matrix, the determinant of this matrix will become 0. Now for the determinant, we will multiply these two elements, it become 2. And after this, we have negative sign in the formula. And after this, we multiply these two values, it gives us 3 lambda and is equal to 0. Now this negative 3 lambda shift on the right hand side will become 3 lambda and divide both sides with 3. So on this side we left with lambda and on this side we left with 2 by 3. It means that it can take all the real value except for the lambda is equal to 2 by 3. At 2 by 3 this matrix will become singular matrix. It means the correct option for this MCQ number 51 is option number B. Move to the next MCQ number 52. It tells that if theta by 2 lies in third or fourth quadrant, then sin theta by 2 will be. So these MCQs can be solved within 2 seconds if you know the behavior and the role of trigonometric sine function in the quadrantal plane. So move to the solution of this MCQs. First we are going to find the value of sin theta by 2. You know that cos of 2 theta, it is equal to, you can write it just like cos of theta and plus theta. You can write it just like cos into theta plus theta, because theta plus theta again gives us cos 2 theta. Now after this, you also know that the work of cos is this, that it can take the both value first, so it become cos theta and cos theta. After this, it change this sign. If it is plus, it will convert into negative. If it is negative, it will convert into positive for cos function. Now after this theta and this theta, it can take by sine, so it becomes sin theta and sin theta. So after this cos of 2 theta, it will be equal to cos theta into cos theta gives us cos square theta, and minus into sin theta gives us sin square theta. Now you also know that in the class 10 we learn the formula that sin square theta plus cos square theta is equal to 1. So now over here we convert this sin square theta, cos square theta into sin square theta. So the value of cos square theta from over here, it will be 1 minus sin square theta. So put it over here, it become cos of 2 theta will be cos square theta from over here, it is 1 minus sin square theta, so put over here 1 minus sin square theta, and this minus sin square theta will comes down as it is. After this cos of 2 theta, it will be equal to 1 sin square theta and another sin square theta, it will give us 2 times of sin square theta. Now after this, shift this one on this side, it become cos of 2 theta, it become minus 1 and minus 2 sin square theta will come down as it is. After this, multiply both sides with negative 1, so it become negative and it become positive, so it become 1 minus cos of 2 theta and it become positive 2 sin square theta. Now divide both sides with 2, so it become 1 minus cos of 2 theta divided by 2, and on this side 2 will cancel out with 2, we left with sin square theta. Now take under root on the both side, so it become plus minus 1 minus cos of 2 theta divided by 2, and square will cancel out with under root, we left with sin theta. Now we are going to find the value of sin theta by 2. How can we make it theta by 2? We just divide the theta with 2 in the whole equation. So over here it become 2 will cancel out with 2, we left with 1 minus cos theta divided by 2 under the root is equal to sin theta by 2. Now they are talking about third and fourth quadrant. So remember, if this is, let's suppose, the origin plane, in this quadrant first and this second quadrant sine lie positive. In the third and the fourth quadrant it lie negative. So in the third and the fourth quadrant the result will be negative, we will neglect the positive. So it means that sin theta by 2 will be minus time of under root of 1 minus cos of 2 theta by 2. This is will the required and desired answer. So the correct option for this MCQs will be option number C. Move to the next MCQ number 53. It tells that if theta is less than phi, then the relation between theta by 2 and pi by 2 is given by. This is actually the statement of this question and this MCQ number 53. They tells that if theta is less than pi, then what will be the relation between pi by 2 and theta by 2 and pi by 2? So move to the solution of this MCQ number 53. We are given with theta is less than phi. That tells that what will be the relation between pi by 2 and theta by 2. So it means that we will just divide both of them with 2. So divide this inequality to the both side with 2. So it becomes theta by 2 is less than pi by 2. This is actually the required and desired answer. Theta by 2 and pi by 2. So the correct option for this MCQ is option number B. Now move to the next MCQ, MCQ number 54. It tells that the value of cos of pi theta plus cos of 3 theta divided by sin 5 theta minus sin 3 theta will be. So move to the solution of this MCQ number 54. We will use two formula over here. The first formula is sin A minus sin B. This will always be equal to 2 into cos of A plus B by 2 multiplied by sin into A minus B by 2. This is first formula. And the second one is cos of A plus cos of B is equal to 2 into cos of A plus B by 2 multiplied by cos of A minus B by 2. Over here, let's suppose this is cos of A and this is cos of B. So putting the values over here, so it become cos of A. A is pi theta, let's suppose. And plus cos of B. Let's suppose cos of B is cos of 3 theta. Cos of 3 theta. So it will be equal to 2 into cos of A is pi theta and B is 3 theta. So pi theta plus 3 theta, it will give us 8 theta. And divided by 2 into cos of A minus B. A is pi theta and B is 3 theta. So pi theta minus 3 theta, it will give us 2 theta and divided by 2. So the value of cos of pi theta and plus cos of 3 theta, it will be 2 into cos of 8 theta by 2, it will give us 4 theta into cos of 2 cancel out with 2, we left with cos of theta. So the value of cos of pi theta plus cos of 3 theta is 2 cos of 4 theta into cos of theta. Now we are going to find the value of sin A minus sin B. So let's suppose sin A is sin 5 theta and sin B is a sin 3 theta. So putting the values over here, it becomes sin 5 theta minus into sin of 3 theta. It will be equal to 2 into cos of A plus B. A is pi theta and B is 3 theta. So pi plus 3, it will give us 8 theta and divided by 2 into sin A minus B. So pi minus 3, it will give us 2 theta and divide with 2. So it becomes sin 5 theta minus sin 3 theta will be equal to 2 into cos of 8 theta by 2, it will give us 4 theta. And sin 2 cancel out with 2, we just left with theta. So this is the value of sin theta 5 theta minus sin 3 theta. Now putting the values over here, cos 5 theta plus cos 3 theta, it is equal to 2 cos 4 theta. So it becomes 2 cos 4 theta multiplied by cos theta. And over here we have division, so divided by sin 5 theta and minus sin 3 theta. So sin 5 theta minus sin 3 theta is actually equal to 2 cos of 4 theta, 2 cos of 4 theta into sin theta. So 2 cancel out with 2 cos 4 theta, cancel out with cos 4 theta, and cos divided by sin, you know that it is actually equal to cotangent theta. So the required and desired answer to this MCQ is option number C. Move to the next MCQ, MCQ number 55. It tells that if absolute of A vector plus B vector is equal to absolute of A vector minus B vector for two non-zero vector A and B, then it holds that option A tells that AB are perpendicular vector, AB are parallel vector, AB are coplanar vector, or AB are non-coplanar vector. So how can we solve that? So move to the solution of this MCQ number 55. We will prove that either it is parallel, perpendicular, coplanar or non-coplanar. So the condition is A plus B vector, this is equal to absolute of A vector minus B vector. B vector. Now I suppose to take square on the both sides. So squaring on the both absolute. So it become A plus B whole square formula, which is equal to A square plus B square and plus 2 times of magnitude of A dot magnitude of B will be equal to A minus B whole square formula. It is equal to A square plus B square and minus 2 times of absolute of A and absolute of B. Over here the formula is A square plus B square minus 2AB, and over here the formula is A square plus B square plus 2 times of AB. And let's suppose these are the vector, so we will draw a arrow on the upper or lower of the AB. So now after this, A square magnitude cancel out with A square magnitude because these are same, and B square magnitude cancel out with B square magnitude. So we left with 2 times of magnitude of A vector and magnitude of B vector, and shift this minus 2 times of A magnitude B magnitude on this side. So it become plus 2 times of magnitude of A and magnitude of B, and on this side we left with 0. Now after this, 2 times of AB and plus 2 times of AB gives us 4 times of magnitude of A can be written as A dot B is equal to 0. Is equal to 0. Now after this, divide both sides with 4. So on this side we left with AB is equal to 0. Now you know that A dot B is actually equal to A magnitude, B magnitude and cos of theta. So put over here A magnitude, B magnitude and cos theta is equal to 0. Now divide both sides with A magnitude and B magnitude. So on this side they are cancelled with each other, and on this side we left with 0. So cos of theta is equal to 0. Remember, cos of theta is equal to 0 when the angle is 90. So it means that both the vectors are perpendicular to each other. So the correct option for this MCQs is option number A. Move to the next MCQs, MCQs number 56. It tells that let a function, compound or composite function is given f of g of x, which is equal to under root of x square plus 1 and minus 1. And another function g of x is given, which is equal to x square plus 1. Then that tells that find the value of the function f of x at the value of x is equal to 4. So first we are going to find the value of f of x from this function. How? First we will find the inverse of g of x. So our g of x is equal to x square plus 1. Now for the inverse, let's suppose I will consider this g of x to the another variable. Let's suppose it is equal to y. So it become y is equal to, let's suppose this is condition number first. So from where it become y is equal to x square plus 1. Shift 1 on this side, it become y minus 1 will be equal to x square. Now take under the root on the both side. So it become y minus 1 will be square on this side. So square will cancel with under root on this side. It become x is equal to square root of y minus 1. Now from over here shift g on the right hand side. It become x is equal to g inverse y. So put x is equal to g inverse y over here. It become g inverse y will be equal to the under root y minus 1. Now I replace y in this function, inverse function, with x. So it becomes g inverse x will be equal to under root x minus 1. Now my original compound function is f of g of composite function is f of g of x is equal to under root of x square plus 1 minus 1. Now over here, how can I find the value of f of x from over here? I will eliminate this g from over here. How? I will put the value of x, g inverse x over here. So replace x with g inverse x, so it becomes g inverse x. And also replace this x with g inverse x. That does not affect the function. So g inverse x whole square plus 1 and minus 1. Now over here g power is 1 and over here it is negative 1. So they cancel with each other. We left with f of x is equal to under root of g of x. So g inverse, this means g inverse x. So g inverse x is actually equal to g inverse x is under root x minus 1. So put over here under root x minus 1, and over here we have whole square plus 1 and minus 1. Now after this, the value of x is 4 over here. We are going to find f of 4. So put x 4, so it become f of 4 will be equal to square cancel out with under root. So we left with x minus 1. So x is 4. So 4 minus 1 it gives us 3, and this plus 1 will come down as it is, and this minus 1 will come down as it is. So the value of f of 4 will be 3 plus 1 gives us under root 4, and this minus 1 will come down as it is, and under root 4 is equal to 2 and minus 1. So 2 minus 1 will give us value 1. So it means the value of f of 4 is equal to 1. So the correct option for MCQs number 56 is option number A. Move to the last MCQs of ETEA Engineering test of Mathematics portion 2017. It tells that derivative of cosecant inverse x will be where x less than 0. So how can we find the derivative of cosecant inverse function? Let's suppose it is equal to a function y is equal to cosecant inverse x. Now shift cosecant inverse on this side. It become over here the power is negative 1. So by shifting to the left hand side it become positive 1. So it becomes cosecant y will be equal to x. Now after this, it can be written as x is equal to cosecant y can be written as 1 over sine y. Now derive both sides with respect to y. So on this side it become dx by dy will be, over here I will use the quotient rule of differentiation for the derivative of 1 over sine y with respect to y. So it becomes sine y derivative of 1 with respect to y, and minus 1 derivative of sine y with respect to y divided by sine y. It is cosecant y, so sine y it becomes sine y whole square. So sine y into derivative of a constant 1 is 0, so the whole term will be 0. So the value of dx by dy will be sin y derivative, you know that it is cos y, so it become minus cos y and divided by sin y whole square, sin y whole square. So it can be written as sin y into sin y. So dx by dy will be cos by sin gives us cotangent y and 1 over sin y gives us cosecant y. Now you know that 1 plus cotangent square y is equal to cosecant square y. So shift 1 on the right hand side, it become cotangent square y will be cosecant square y minus 1. Take under the root on the both side. So the value of cotangent y will be under root of cosecant square y and minus 1. Now putting the value over here, now reciprocate both sides, so it become dy by dx, and on this side cotangent y cosecant y will move to the denominator, so it become 1 over cosecant y into cotangent y. So the value of dy by dx will be minus 1 divided by cosecant y is actually equal to x, so it become x, and cotangent y is under root of cosecant square y, so cosecant is actually x, so it become x square minus 1, x square minus 1. So the required derivative of cosecant inverse x dy by dx is minus 1 over x under root of x square minus 1. Correct option for this MCQs is option number B. So with this MCQs, ETEA Engineering Mathematics portion MCQs has been completed. So thank you for watching. Subscribe my channel and also hit the bell icon to receive the upcoming notification about mathematics. Thank you.